Going on, guys. In this video we are going to see how to do the line integral of a curve, and in this particular problem we are going to see how to do the line integral of this given curve in this region. And if you look at this region, this is going from 0 0 to 2 4. 0 0 is this one, 2 4 is here. The region is already drawn here. But before we go and do this problem, let's look at this equation. This is the equation for the line integral of a curve, and this C is the curve, and then the equation of the curve is given by f of xy, and ds mean this is the arc length formula, so we are going to integrate this one with respect to ds. And when we do the line integration, what we have to do is we have to parameterize this xy variable respect to t in terms of t. So if you do the parameterization, the function is going to be f of x of t, y of t. Then this ds is the arc length formula, and if you remember, for a multivariable function we find the derivative of this variable and square them and add them together and square root. That's the equation of the arc length for a multivariable function. That's why we have this one here, and that's how we derive this formula. This is the formula for the line integral of a curve. Now let's go ahead and do this one. Here we have this graph, and if you look at this graph, when x is equal to 2, y is equal to 4. So from this one we can say y is going to be equal to 2 times of x. Okay, and if we let x is equal to t, y is going to be equivalent to 2t, and here we know that t is equal to x. So if you look at the x region, that's going from 0 to 2, right? So this is going to be our region, 0 to 2. Then what we have to do is we have to parameterize this function, given function. Let's say this r of t is equal to t comma 2t. Now we are going to rewrite this function in terms of t, and when we do that, we are going to change x into t and y into 2t. So this is going to become t plus square root of 2t, and that is this function. Okay, now we have taken care of this part. Now we have to find the derivative of this x and y respect to t in order to do this part. Okay, now let's take the derivative dx by dt, and if you do the derivative of this one respect to t, this is going to be just 1, and if you do the dy by dt of this one, that's going to be just 2. Now we have everything. We can go ahead and write our integral equation. Okay, now integration is going to go from the t region, so that's 0 to 2. 0 to 2 is the limits of integration. Now f of x, x of t, y of t, that's our parameterization function, and that function is here, that is t plus square root of 2t. So that's going to be t plus square root of 2t, and then this formula, this arc length formula, is going to be x prime square plus y prime square. We already found that one. X prime is 1, so 1 square plus 2 square, and we are going to integrate everything respect to t. And if you do this one is going to be 1 square plus 2 square, so this is going to be 5. Here we are going to have 5, and here we have t plus square root of 2t, and this is a multiplication. Okay, and we are going to integrate everything respect to t, and this is going from 0 to 2. Now we can move this square root of 5 to the front because this is a constant, and also we can separate this equation, like we can do the integration individually. So if we do that, this is going to be 0 to 2 t dt, and here we are going to have 0 to 2. Instead of writing square root of 2t, we can write it like 2t power half. Okay, dt, and that's it. Now let's do the integration. Now let's get rid of some of these parts because we need some space. Let's get rid of this part. Okay, so for the first one, the integration is easy. If you look at this one, the integration is going to be just t square over 2. Okay, and that's going from 0 to 2, and we are going to have square root of 5 remaining in the front. And also we have this one. For this one we can do the u substitution, and if you let u is equal to 2t, then dg is going to be 2 dt. Okay, since we have dt alone, we can rearrange this equation. So dt is going to be dg by 2, Now let's continue this part right here. Okay, now let's write this one, rewrite everything. So square root of 5, if you plug 2 for this t square, this is going to be 4. 4 divided by 2, that's going to be 2. So here we are going to have 2. And let's do the use of integration with respect to u here. For this one, we are going to do the integration of this one. Here we know that this is 2t power half, and we know that u is equal to 2t. Instead of 2t, we are going to place u here. So this is going to be u power half, and instead of dt, we are going to replace that one with du by 2. So this is going to be du by 2. I move the half to the front, so because half is a constant, so we can do that. Now let's do the integration. If you do the integration for this one, this is going to be half u power 3 by 2 divided by 3 by 2. Instead of dividing by 3 by 2, we can multiply this one by 2 by 3. Okay, and here we have 2 plus, and all everything is going to be multiplied by square root of 5. And the limits of integration, when we have t, we had 0 to 2, and when we replace this one with u, we can find the new limits of integration. If you plug 0 in this function, 2 times 0, that's going to be 0, and if you plug 2 for this function t, so this is going to be 2 times 2, that's going to be 4. So the new limits of integration is going from 0 to 4. Here we are going to have 0 to 4. Now let's get rid of this part. Okay, let's get rid of this part, and let's continue here. Okay, here we have root 5, and then here we have 2. These two cancels, so we are going to have 1 over 3. And then if we place 2 for this u, this is going to be 4 power 3 by 2. Instead of writing 4, we can write 2 square power 3 by 2. And if we plug 0, that's going to be just minus 0, so we don't have to write that one. And 2 square power 3 by 2. And from this one, you can see this square and this half cancels each other. So we get 2 power 3. So this is going to be 8 over 3. So square root of 5 times 2 plus 8 over 3. And if we take the common denominator, this is going to be 6 over 3. 6 over 3 plus 8 over 3, that's going to be 14 over 3. 14 over 3 multiplied by root 5, that's going to be 14 over 3 root 5. And that's going to be the line integral of this curve. And that's how we do this kind of problems. I hope this helps. Thanks for watching.